Hi, welcome back. So today is an exciting day because we're going to start drawing fractals, and the first fractal which we are going to draw is the cool triangle fractal which I showed you in the last video, and which is called the Sierpinski's triangle. Now this fractal is centuries old, but it was extensively studied by a mathematician called Wacław Sierpiński. So it's named after him. Okay, so let's start drawing the Sierpinski's triangle. So it's a simple three-step process to draw the Sierpinski's triangle, where one of the processes is repeated as I told you in the last video. Okay, fine. So first step is to draw an equilateral triangle. Okay, so an equilateral triangle is basically a triangle where the three sides of the triangle are equal in length. Alright, now this might be tough if you don't have a protractor or something, but you can even do it freehand as I'm doing it right now. So yeah, so you can see like the three sides are roughly equal in length. Alright. Okay, fine. So the second step of drawing the Sierpinski's triangle, the second step is join the midpoints. Join the midpoints of each side of the triangle to form an upside down triangle. So join the midpoints of each side. So midpoints is like the point between these 2 points. So that's basically this, and this. Now if you join these 3 points, it's a little bit this. If you join these 3 points, then you get another upside down triangle. Alright. Now step 3, and here's where the repeated process comes in. Step 3 is repeat step 2 for each upright triangle formed. Upright triangle, so that means it should be facing on the top, so the point is upwards, so it's like this. So every upright triangle drawn, you draw another triangle inside that upright triangle. So for example, here there are 3 upright triangles, and we'll ignore this triangle for now. Alright, so for each of these 3 triangles we'll draw a triangle inside each of them. So let's see here. And we keep on repeating step 3 again and again and again, and we draw more iterations of the Sierpinski's triangle. So for each of the upright triangles which are formed, you draw more triangle inside them. So like this. And you can keep on doing this for as much as you like. Okay, so this is the Sierpinski's triangle. Now, what I encourage you to do is draw the Sierpinski's triangle on your own, but what I really want you to do is be creative and make it your own. So, here's one thing really important to understand about fractals, that anything which satisfies the three properties which I talked about in the previous video, self-similarity, fine structure at small scales, and repeated process, anything which satisfies these three properties is a fractal, and you can make your own versions of the Sierpinski's triangle and be creative with it. So let me give you some ideas. So what you can do now is, for example, who said that we have to draw one triangle inside of the larger triangle we are talking about? So let's say we have this triangle. We can make three triangles inside this larger triangle instead of just one triangle. So we can make something like this, and for each upright triangle formed, which includes the middle triangle here, so 1 2 3 4, you repeat this process of drawing three triangles, something like this, and you keep repeating that process again and again and again, and you can get a really interesting fractal. Alright, so that's one thing you can do. Another thing you can do is use color pencils. So if you have color pencils or crayons at home, then you can use colors, but it's not necessary. As you can see, it's like even with pencil it can look really cool and interesting. What you can do is use the Sierpinski's triangle in conjunction with other shapes. So for example, you can make a hexagon like this, and you can divide the hexagon into 6 equilateral triangles. And make each of these triangles into a Sierpinski's triangle. Alright, or you can make spikes on this hexagon and make even each of these spikes into a Sierpinski's triangle. Alright, like again, yeah, drawing triangles inside all of each of these triangles. So you can do that. You can not choose to start with the equilateral triangle. For example, you can start with a right angle triangle. Nobody said we have to start with an equilateral triangle, so we start the right angle triangle, and then within this right angle triangle we draw another right angle triangle like this, and then you can keep on doing, right? Yeah, so you can see, like, there can be many versions of the Sierpinski's triangle, and I only touched on some of them, and I hope you enjoyed the video and you can make your own version of the Sierpinski's triangle and surprise me with it. Alright, surprise me with your own creativity or imagination. Alright, thank you.